All right, as soon as I get this going, give me a minute to get that. From 60. All right. So the last thing we were doing on Monday, almost said Wednesday, today is Wednesday. On Monday was we defined the function and the variable and we entered the equation and created the graph. Okay, all right, so before we pick up on the rest of this problem, one of the things that I am doing is stressing the ordered pair. So on example 2, when you deal with an ordered pair, the first number is always your variable, which in this case is t, and it represents days. Now, on this is just for my information, so I'm not going to be as specific. And I can always go back to this definition of it when I'm answering the question. And the function is A, which is grams of, I'm just going to do R223, radium 223, and it's measured in grams. Okay. Now, the thing to remember is in relationship to our calculator, this is your X and this is your Y. Okay. Now, here in a little bit, I'm going to tell you why I am stressing this so much to you. Okay, so when we come down here to part B, it says, what was the largest amount of radium-223 present over the first 60 days? This word largest tells me we're looking for what?
Exactly.
The maximum. All right. So we've already got our y equals in there. So we want to find the maximum. So we go to calc. Is it 4? 4's maximum, right? Yeah. All right. So I'm going to go to second calc 4. Now, this is what you have to remember. If it says left bound, you need your cursor to the left of the peak or the top of the hill. Yours may already be there, but I can see mine blinking on the right. So I'm going to left cursor it over to where I know it is to the left of the peak. And now I'm going to push enter. Now it says right bound. So now I need my cursor to the right of the top of the hill. Push enter. I don't want it to guess. And then I push enter again. And now I get an X and a Y value. Okay, so I'm going to write those back both down. So they tell me that X equals 20.95. And they tell me that Y equals 0.482. I just chose to go that many decimals. Just pay attention to what is done. Okay. So what we have found is that is this maximum's ordered pair. So the X, so that tells me that if I go down to my X axis, this is 20.95. And if I go over to my Y axis, this is 0.482. That's what that ordered pair gives us. Okay. So then what I'm going to do is go, okay, X and Y is what we refer to when we're talking about the calculator, but this particular problem, it's not X and Y, it's A and T. So what I'm gonna do is I'm gonna rewrite this as X is the variable, my variable is T. So I'm gonna say T equals 20.95, and that is days since experiment began. So I know this is days since experiment began. And then Y is my function, and in this particular problem, our function is A, which is 0.482, and this is grams of radium-223. Okay, so before we actually answer the question, let me tell you why I go through all of that. So if you will take the time to define, label your axes, create the ordered pair and label that. When you get the two numbers, get everything labeled. Then when you go to answer the question, in my opinion, it makes it a whole lot easier. If you start going straight to the calculator, punching things in, not writing anything down, and starting to grab numbers, hoping it's what they're asking for, you're actually going to spend more time. You think you're doing it quicker, but what's going to happen is you're going to get it wrong on the first attempt. You're probably going to have to do a second and then maybe a third attempt. And then you're going to go, oh, I better do the read it and or watch it. And then by the time you get to the fourth or fifth attempt, you get it right. If you'll take the time to do all of this, most likely you're going to get a correct answer on the first or second try. So it actually takes you less time. Okay. All right. So we have all the information. Now I've got to figure out what it's asking. What was the largest amount of radium-223 present over the first 60 days of the experiment? Which one's it asking for, T or A? Remember, the word what is typically your function. It's asking for radium-223 present. So this particular question, this is my answer. Now, in WebAssign or on a test, a lot of times you're also going to have a question that says, when did this happen? And so that would be that answer there. Okay, but it didn't on that one. All right, so part C. What was the largest amount of radium-223 present over the first 10 days of the experiment? Okay, this is what you have to pay attention to over the first 10 days. So I'm going to come up here and see if I can kind of wrap my head around what they're referring to on my graph. So here at the maximum, that was 20 days. So would you agree with me that 10 days would be somewhere around here? Yeah. And it's asking for what was the largest amount of radium. So we're looking at the first 10 days, which is only this portion of the graph. We're going to disregard everything else. And it says, what was the largest amount over these first 10 days? Largest amount means the tallest part of the graph that you're referring to. So over the first 10 days, this point right here is the tallest point. And it is asking us to find this amount here. Right? Everybody okay with that? So in this particular problem on part C, what was given? When you read down here, what's given? 10 days, right? Did they give me variable or function value? Yeah. Variable value. They gave me variable value, which means T equals 10 days. But in my calculator, then what that means is they gave me x equals 10. I have to find the function. What is that on my calculator? Value. That's value. It's exactly right. So you're going to go to your calculator and you're going to do calc 1, which this is value. Second calc, I'm going to do 1, which is value. And it's asking me to put that value in. So I'm going to enter x equals 10. And hit enter, and it gives me y equals point, I'm going to do 389. So it gives me y equals 0.389. But for purposes of this problem, my y is the function a. So I'm going to write this as a equals 0.389. And then how do I label what A is? You can go to your graph. You can go to your ordered pair. You can go here. It's grams of radium-223. Now, we've answered the question and it is correct. I am going to go back to my graph and make sure it makes sense. So I'm going to come up here because what we have found is that this is 0.389. In relationship to the 0.482, if this would have been 38.9, would that have made sense? Down here is 0, and as you go up, the numbers get larger. Would it make sense to have a whole number 38 come before 0.482? No. So 0.389 is smaller than 0.482, so it does make sense in relationship to my graph. Because sometimes you'll get wonky answers, and if you don't ask yourself if it makes sense, yep.
Can you also use the table graph to find?
Yeah, you can use table. You just have to go in and do a table set, and then all of that. So, all right. Example 3. The temperature T equals T at D. Okay, right there, I can determine what is my function and variable, even before I read any further. By looking at that, I know my function is T, and I know my variable is D. So I'm going to keep reading and see. Okay, so the temperature in degrees Fahrenheit of a patient during an illness is modeled by the function. Here's your equation where D is the number of days since the illness began. Okay, well, right there, they point blank told me what the variable is. So it is days since illness began. So if you go reading, what would you tell me temperature, I just told you. What would you tell me T is? Temperature and in what? Yeah, temperature in Fahrenheit degrees. All right, so again, before I do anything else, I'm going to go ahead and write my ordered pair. And I know the first one is always your variable. So that is D, which is days since illness began. And my function is T, which is going to be Fahrenheit degrees. That's your temperature. Okay. All right. So first thing it asks me to do is make a graph. I'm going to label. Bless you. Bless you, bless you, bless you. You're just wanting lots of blessings today.
That's cool.
So temperature in Fahrenheit degrees. D days since illness began. All right, so we know that we're going to go to Y1 equals and enter the equation. We're going to go to window. Anybody found the min and the max? first 12 days. So that would be day 0 to day 12. And then we'll do Zoom 0. Okay, so before I enter this in my calculator, look at the equation. We're talking about temperature, right? Did you guys notice anything in the equation?
Temperature of the body.
98.6 is when we have no fever, right? So if I put in 0 days, this would all go away, and so my normal temperature is 98.6. Just being observant is all. All right, negative 0.1 x squared plus 1.2 x plus 98.6 window, what did I say, 0 to 12? Yes. And then Zoom 0 and be patient. It's called a parabola. It's concavity. Go down. Mhm. Perfect. All right, so it looks kind of like this, 0 to 12. All right. When will the patient's temperature be? And then I see the word highest. So what does that point you to?
Maximum.
Maximum. Which is the peak or the top of the hill. So we're going to be finding this and this. So, is that Calc 4? Is that correct? Second table 4. Okay. Ooh, I'm getting ready to sneeze. Look at the light. It'll go away. All right, left bound. I can't really see my cursor, so I'm just going to go over till I kind of see that it is to the left. Enter. Now I'm going to do the same thing and put it to the right somewhere. Doesn't matter where, just as long as it's not, just as long as it's to the right of the top of the hill. Yes, enter. And so I get x equals 5.1234 1 2 3 4 5 3 2, and I get y equals 102.2. Okay, all right, so I'm going to figure out what those represent. What's your variable in this problem? Not x, but d. So d equals, now y'all, there's all those 9, so even if we went out 1 2 3 decimal places, what is this going to round to? 6. So I'm going to say 6 days. And then instead of y, this is t, which is 102.2 degrees Fahrenheit. Okay, so here's what we found. We have found that the peak of, does it give us a person, the patient's, the peak of their temperature is at 6 days, and it peaked out at 102.2 degrees. Okay. So I've gotten a lot of information. Now I got to figure out what it's asking so I know what to correctly put into WebAssign or correctly circle. Because if you circle both of these, I'm going to count some points off because you're not telling me you know what it's asking. Okay. So it says, when will the patient's temperature be the highest? Is it asking for the 6 days or the 102.2? When is typically asking for the variable. When at 6 days. So for this one, this is the answer it's asking. What's the word that it would use if it was asking for the temperature? What? And what do you know? Part C. what is the highest temperature? So we're still looking at my maximum. So what is the highest temperature for the patient during this disease? So now it's asking for the temperature, 102.2 degrees Fahrenheit. Okay. When will the patient's temperature be 101 degrees Fahrenheit? What was given, variable or function? Function value, which is T equals 101. Okay, we don't use Calc 1 in this one. The only time you use Calc 1 is when you're given the variable. We're given the function. How do we do that in our calculator? This is your Y2. So we'll do, I'm gonna go ahead and write it all. So this will be your Y2. We already have, oh, darn it, I forgot the one. Already have this in our calculator as Y1. So put in Y2 equals 101. Then what do we hit? Graph. So this is the only time we go straight to graph. It's going to show me where that's located, which when I come up here, that makes sense, right? Because here's 102. So somewhere around here is 101 degrees. How many times did the patient hit 101 degrees? Twice. Okay. So we're looking for when the patient hit 101 here and when the patient hit 101 here. Okay, so what do I go to next? Yes, so this is Calc 5. Now I need to show you something because we have 2 of them that we're going to have to do. All right, so my cursor appears to be way at the top. I'm going to move it closer to the first intersection. It doesn't have to be on the intersection, but I just want it close to it, okay? So if yours isn't kind of over to that first one, go ahead and move it. So then I'm gonna hit first curve, enter, second curve, enter, guess, enter. And so it's gonna give me X equals 2.536. But now I have another one. So you're going to go back to Calc 5, second Calc 5. Okay, but here's the key. If you start hitting enter, 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 it's going to give you this same one again. So now what I'm going to do is move my cursor to where it is closer to the second intersection. Right. Move cursor close to second intersection. And now what I'm going to do is first curve, enter, second curve, enter, guess, enter, and now you'll see that my cursor is on that second one and we get X equals 9.464. 464. Okay, so again, my variable in this is T. So this is T equals 2.536 days. And this is T equals 9.464 days. Now, pay attention in WebAssign what it's asking for, but let's think through this a little bit, okay? So here's 0 days. And as I go up the curve, I'm gonna hit 1 day, and then I hit 2 days, and then of course I hit 3 days. Is 2.5, are you still in day 2, or have you gotten to day 3 yet? You're still in day 2, right? So their temperature of 101 hit on day 2. And then as we move day 6, the patient's temperature peaks, and then it starts decreasing. And then on day 9.464, we hit 101 again. But are we still in day 9, or have we gotten to day 10? We're still in day 9. So in this case, your answer would be day 2 and day 9. And here's the reason I point that out. If you went to solely rounding, you would have said 3, day 3, because 2.5 rounds to 3, but technically we haven't hit day 3 yet. So on problems like that, you have to be careful and think through what's going on, okay? All right. Last problem of the day. A model for the spread of a certain epidemic is given by the formula. Okay, when I look at the formula right here, the letter that stands alone, N, is always your function. The variable is always within the equation, and that's T. So I'm trying to figure out what N and T represent. Where, oh, nice. N is the number of new cases per day. Okay, so number of new cases per day. And T is the number of days after outbreak. Days after outbreak. So I'm going to go ahead and do my ordered pair as well. Variable is always first, and this is days after outbreak. I'm just going to write days for now, just so it will give me a quick memory trigger. And then function is N, and this is number of new cases. Y'all, I'm going to guess hospitals did something similar to this during COVID, because they were, you know, how many days since the outbreak, how many new cases, because they were wanting those new cases to diminish, so they know that we kind of had hit the peak in the, did you ever hear we need to flatten the curve? That's what that's talking about. Okay, make a graph. All right, so here we go. In number of new cases per day, T days since outbreak. All right, so we know we're going to do Y1 equals window. They got my min and my max yet? Here, 30. Up to 30. All right, let me catch up to you. That's a 30, number 36. All right, cleared out. Oh, okay. Alpha, Y equals 1. 75,150. E is second. LN, which represents natural log. It's over on the left side of your calculator. 0.3x. Denominator, open parentheses, 500 plus second LN, 0.3x. Now I need to put in those closed parentheses. You have to right arrow over. close the parentheses, and then notice there is an exponent of 2. And if you neglect to put that in, then your graph's gonna be off. I'm gonna push x squared, so it'll square that. So window, 0 to 30, zoom, 0. Give it some time. All right, so it appears to have just stopped here, so it looks something. And it just stopped at 30, and this is 0. Not a great picture, but kind of. Okay. We all okay? Okay. What is the greatest number of new cases? So here's your keyword right here, which tells you that you're gonna locate what? That's the maximum. So we know we're gonna do calc, is it 4? Yeah, 5 is the intersection. Calc 4. All right. My cursor is definitely to the left. I'm just gonna go ahead and move it up a little bit because I know I'm gonna have to move it again, but it's still to the left. I'm gonna hit enter. Now I need to be sure it's to the right of the maximum. And there it is there. Enter, guess, enter. So I get x equals 20.715. I'm gonna go out 3 decimal places. And I get y equals 37.575. Is that what you guys are getting and seeing? Okay, so x is my variable, and my variable in this problem is t, because I can look up above where I define that in my ordered pair, and it's days. So I'm going to say t equals 20.715 days after outbreak. And y is my function, which is n, 37.575 new cases per day. Okay, so that is my maximum right here. Just so I can keep a visual, this is 20.715 days. $37.575 new cases. Okay. All right. So I've done all the hard work. Now I'm going to read the problem. All right. So the first thing that it asks is, what is the greatest number of new cases we expect to see per day? Are they asking for T or N? Which one? N. The function typically goes with the word what? Then it says, when does this occur? Your variable is typically when. So this particular question asked for both of those. Okay. All right. The local medical facility can handle no more than 25 new cases per day. During that, or during what time period will it be necessary to recruit help from outside sources? Okay, so here's what they've given us, 25 new cases per day. So what was given, variable or function? Yeah, new cases is function. So they gave us function value n equals 25. So how do we handle that in our calculator? That's your y2. So you're gonna have 25. That's gonna be your y2. You already have, let me go ahead and write it. This is already in your calculator as y1. All right, so I'm gonna go in and I'm gonna put in y2. Now, where do we go? Not trace, but I want to see it on my graph, so I'm gonna go to graph. Then I'm gonna come up here. So here's 37 new cases. This is 25 new cases. Now, think through this. They can only handle up to 25 new cases per day. So from here up to 25, they can handle that with normal staff. Then they need extra help. And then once they hit 25 cases again, they can handle it without the extra help. So we're looking for these two intersections because it's from this day to this day that they're going to need additional help. So we're going to go to Calc 5. And I want to put it near the, yeah, mine's near the first intersection, so it's okay right where it's at. First curve, enter. Second curve, enter. Yes, enter. And I can see it's going to land on that. And it gives me x equals 16.314. So then I've got to go back to Calc 5, and then you're going to have to move cursor closer to the second intersection. Move it. And now I'm closer to that intersection, so I'm going to hit enter, 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 and I get x equals 25.117. Okay. All right. So what do both of these represent? Days, right? So here is your 16.314, but that's during day what? Have we gotten to day 17 yet? No. So we need help on day 16, 2, and then we need help until we get here, which I can't write it in there. I've got too much going on. That's 25.117. So here's 25.117. Again, are we on day 25 or 26? 25. So this is your actual answer. All right. After the first 15 days. Okay, so when I come up here to my graph and see if I can figure out what they're talking about. Well, here's day 20. Here's day 16. So would you agree with me that day 15 would be somewhere around here? Okay, and it said from day 15 and after. Okay, so I'm looking at only the pink highlighted part. After the first 15 days, when is the number of new cases the smallest? So the smallest, so here's my highest level of new cases. So the closer we are to the bottom of this is my smallest cases. So where at on my pink highlight is the lowest point? Is this the lowest point? Is this the lowest point? No, look at your end points. Are your two end points the two lowest points? So you're talking about day 15 and day 30. Well, which one appears to be lower? 30. Day 30. So here is after 15, your lowest or your least amount or smallest. So when is that? So when did that occur? You just told me. Yep. So that's the first answer. That's your win. And then it says, how many new cases were there at that time? Okay, well, think day 30. What is given? So you're given the variable value of t equals 30, which in our calculator, that's x equals 30. So what calculator operation do we use? Calc 1 value. It's going to come up x equals, and then you're going to put in 30. And then you're going to hit enter and your y. So y equals 8.228. So y equals 8.228. And we know that that's the function, which in this case is what? N? 8.228 what? New cases per day. Okay. All right, shut this off, and then I've got two more things I want to say to you.